Hello everyone in CIS-115. Welcome to the final module of the class. This is some really neat material on how we can work with images and do Photoshop type things with Python. And basically anything that you can do in Photoshop, we can do in Python, only better. So it's been a long journey since we started the class back 14 or 15 weeks ago with Turtle Graphics, and now we're going to be working with making some graphics, particularly images, and you will see that when we get into this that the computer actually saves the image as just some numeric values for each dot on your screen. So let's click into the imaging lecture and we'll get started with this material. So one thing that you have to have in order to do the programs, to create these programs that we're going to do, is you need a little add-on library, and I'm pointing to it right here. It's called CImage. That's a little c and a capital I, CImage.py, and that's going to have to be saved in the exact same folder as the programs that you create. And also, if you're going to work with any pictures, unless you're going to specify where they're located, those pictures need to be in exactly the same folder. So, CImage is a little helper library that was developed at Luther College for computer introduction to computers, introduction to programming and logic classes. So it basically makes our life a little bit easier when we're working with these images. So just so I don't forget, I'm going to go ahead and right click that and save it down to my folder where we'll create some of these programs. So, and if you're using Chrome, you've got to be kind of careful, because Chrome doesn't let you specify, I don't think, where the downloaded file goes. In Firefox, which is what I'm using here, I can right click that file and save link as, and it will let me say where I want it. And so I'm going to save it in my imaging lecture folder. And so now if you look in my imaging lecture folder, you can see there's the CImage file that has to be where in the same folder with our little Python programs. So, and I'll go ahead and save the image of the battleship here that I took down at Wilmington. So I'm saving that down to my imaging lecture folder as well. And just as a double check, now you can see the battleship image, and you can see the CImage little helper library that we're going to import into our programs. So now that we've got that out of the way, just a little background. Python doesn't usually ship with a version of the Python imaging library that works with JPEGs and PNGs, which are two other types of images. It mainly works with GIFs unless you install something called Pillow. So if you want to be able to work with lots of different kinds of images, you don't have to do that for our projects. I'm just giving you this information in case you want to work with images later after the class or something. If you want to be able to work with PNGs or JPEGs or bitmaps or TIFFs, then you'll need to go into Tawny, Manage Packages option, and install the pillow library. Now, I have actually gone ahead and done that with my Python here, and you can see what I'm talking about. Here's Tools in Tawny, Manage Packages, and if I type in pillow and hit search, you can see that it's already installed. I've already installed that into my Tawny. And here's the little link for the website that you can see all the kinds of things that they do with Pillow, and it's just some really neat capabilities that they can do working with images using that little library. So, and if for some reason you're not able, and again, you don't have to do this, this is just optional, but if you are trying to add Pillow and you can't get it to install, most of the Macs and Linux computers have a C compiler built in that when you download something with pip, if it's not already built, it'll actually call that C compiler and build it. Most Windows computers don't have the C++ compiler on Windows, so you would need to download something called a wheel file if it won't just install through Tawny and Manage Packages. And wheels are actually the pre-built library that's already been compiled, and there's a ton of them out there, and this is probably the best site right here for wheel files. If you're looking for a wheel to do something on Windows for a Python library, this is the place to go. And I'll click on it just so you can see. It's at University of California, Irvine. And if you scroll down, look at all these wheels that they have built for all these different computer systems, and Pillow's right there, and you can see that if you're gonna get a wheel, it has to match your type of computer. And you'll notice that it's got Win32 and Win64. That's because there are different versions of Windows. There's a 32-bit version of Windows, and there's a 64-bit version of Windows. This where you see 3.7 and 3.8, that's the version of Python. So if I had a computer that had Python 3.8 and it was 64-bit Windows, then I would need this wheel right here. And so that's just a little bit about wheels, and what Tawny actually calls behind the scenes when you click on Manage Packages is it calls the pip program, which is the Python Package Manager program. And that's a really neat program that does all the work for you. You can just type in pip and install and Pillow if you were doing this from the command prompt, and it would install that package. It would actually go out to the internet and download that package and put it on your computer. But if there wasn't a wheel for it that it could find, then you would need to go through those steps that I was just telling you about here of where to go get wheels. So now you know how to go get a wheel for all kinds of stuff. I've gotten wheels for low energy Bluetooth to control robots and things. So if you can dream it up, there somebody's probably already got a wheel out there for the Python library that you're wanting to work with. So main takeaways from that: pip is the Python Package Manager program. If for some reason you're trying to use Tawny and Manage Packages and put some sort of library into your Python program and it doesn't work, then you may need to go get a wheel. Okay? So, all right, let's talk about how computers draw an image. And here is a little picture I took of several different computer monitors, and you can see, I don't know if you've ever done this or not, but if you get really close to the screen of a television or a computer monitor, you can actually see these little dots. And so the way a computer makes an image is by just playing color the dots. And those dots that it's coloring are called pixels. And you can see the definition of a pixel here. It's the smallest display element of a picture. So, and I'm sure you've heard folks talk about the cameras in their phones. And, they measure how good the camera is by how many pixels. That's how many dots it can break the picture down into. And basically, the more dots that you break it down into, the finer the resolution and the more clear and better looking the picture is. So more dots, better picture. We said the dots are called pixels. So when they talk about cameras in phones now, they talk in terms of megapixels. And so a 12 megapixel camera would be better than a 4 megapixel camera. Okay? So, and you can see pixel color stands for picture element. So let's talk about color models. There's two color models that are in common use. Now there are several others, but the two that we're going to talk about, the two main ones, are subtractive and additive. Now, if you're working with paint or ink, then you're working with what we call a subtractive color model. Okay? And I'm sure you might have done this, but if you've ever had some different colored paints and you mixed them all together, you ended up with black. And that's what I'm trying to show you here in this picture. Printers, paints, crayons all use this subtractive color model. And that means that the more color you add, the darker it gets. Okay? And adding all the colors together makes this black color that you see at the intersection of all the circles. Okay? Now, the subtractive color model is also referred to as CMYK. And if you've ever had a printer where you had to buy cartridges for either a color laser or a inkjet, if you get the kind of printer that has the individual cartridges, then you probably had a cyan cartridge. You probably had a magenta cartridge, and you probably had a yellow cartridge. And just to save ink, a lot of them will have a black cartridge as well. So the K in the CMYK model stands for black. C stands for cyan, M for magenta, and Y for yellow. Okay? So we don't use this subtractive model when we're working with computer monitors and images that are shown to you on the monitors. We work with a different model. Your computers, when they show an image, or your phone, when it takes a picture, uses an additive color model. And one example of an additive color model is the RGB model. And that stands for red, green, and blue. And so we said that we're using an additive color model. So if you max out the red, you max out the green and you max out the blue. Right here in the middle is where they're all maxed out, and you can see that we got white. So we actually refer to an RGB color with something that looks like this. You see the parentheses, and it has 255, 0, 0. Okay, the 255 comes from the R, the red in the RGB. So in this particular color that we've made right here, by mixing those three red, green, and blue colors together, when we mix all of them together and we have the red maxed out and no green and no blue, we end up with a bright red. That's as brighter red as it can get, because our numbers for each color range from 0 to 255. Okay, now where's that 0 to 255 coming from? This is what we call an 8-bit color model. An 8-bit color model. So a bit could either be a 1 or a 0 in binary. So if you take 8 and raise it, if you take 2 and raise it to the 8th power, you'll get 256. The 2 comes from the 1 and the 0, okay, because we could either have a 1 or a 0. And if we have 8 of those that we're putting together to make a number, then 2 to the 8th power is 256. And so, since computers start counting at 0, we actually have 256 colors possible, or numbers possible. But 0, if all of our colors here, when we had this, if we had 0, 0, 0, in other words, 3 zeros, then that would be black, because there would be no light at all. Remember, we're using an additive color model, so if there's no light at all, then it's just black. Okay? So here's an example of what those numbers would look like. We've already done this one. 255, 0, 0. That gives us a bright red. Okay? And if we had 0, 255, 0, that would be a bright green. Okay? So, same with the blue is the last one. Remember RGB, red, green, blue. So we have no red, no green. We have the blue maxed out. So that would be a bright blue. And then we can start blending these colors. And you know, the reason they use RGB is you can make any color in the rainbow, any color out of red, green, and blue, just mixing those colors together. So here's an example of making magenta. If we take the red and we take the blue and we max both of those out, red maxed out with blue, that gets us the magenta color. Yellow, if we max out the red and we max out the green, we get a yellow color. Cyan, if we have no red, we max out the green and the blue, we end up with cyan. Now check out white. Like I told you, it's an additive color model. So if we max out the red, the green, and the blue, we end up with a white color. And lastly, if we have all the colors set to 0, we end up with black. Okay? Now, we are talking a little bit about color theory next. So this is what's known as a Berg color wheel. A color wheel. And folks that mix paint or tint paint are very familiar with this color wheel, and it's useful because if you want to, if you've got a something that is too red, if you want to take some of the red out, you can add green. So, or if you want to make something look more green, you can take some of the red out. Okay, so it's basically, if you remove the red, you get green. It goes towards a green tint. If we remove the orange out of our color, it starts taking on a blue tint. So whatever you remove on this side makes it more of what's on the other side of the wheel. So again, if I remove the red from an image, if I reduce the red in the RGB, if I reduce the red, it starts becoming more green. Okay? And we were talking about those pixel numbers, and here's some ideas of how many of those little dots you would have. If you have an 8 megapixel camera and you take a picture with that, it breaks that picture down into something that has 3,264 dots wide by 2,448 dots tall. So that's a lot of dots, okay? And you can see the screen resolutions of laptop monitors, and your old TVs had a res of about that. Now, of course, we've gotten where we have TVs that are, 4K, 4,000 pixels. That's a lot. So this is the way we work with images, as these color in the dots. And so we can make a little program to draw this image right here. So I'm going to walk you through creating a program to draw this image that has one solitary little red dot in here. Now, I want you to look at all these empty dots for a second. And these images get really big really fast. If you have a 12 megapixel camera and it's got to map out all those dots, that picture can be very big. So your cameras typically take pictures as a JPG, a JPEG file. Okay? Now, the downside to JPEGs is they do lossy compression. So what that means is if you save an image, if you take a picture, which your cameras they don't usually give you a choice. Pretty much all of them just save that picture as a JPEG. My iPhone doesn't have another option to save it as anything but a JPEG. But if you save something as a JPEG, it does lossy compression. And what that means is every time you save a JPEG again, you're throwing some of the pixels away. And that means that how many times, if I was borrowing money from you, and I was say I was borrowing $5 from you, and I paid you back $4.85. How many times could I borrow $5 before you'd be out of money? So let's read about, see what it came up with when I just typed in JPG. What's it say? Lossy compression method for digital images. So you're throwing stuff away every time you save that file. It throws things away to make the file smaller. So some better picture formats are PNG. PNG, when you see when I type that in, what's it say? Portable network graphic, family of lossless compression. So if I've got this super duper picture that I've taken with my phone, and I don't know, you've heard of these people that take pictures of something happening, and then the news folks pay them a couple $1,000s for that picture of that tornado or something. You might want to save that picture as a JPEG, open it up in Photoshop or GIMP. GIMP is the program that I use to work with images because it's free. But you might want to open that JPEG image up and save it as a PNG so that you're not throwing stuff away every time you save it. PNG, portable network graphic. Another nice thing about the PNG files, you can do transparency and things. So PNG is a lot nicer format than JPG. So portable network graphic. Just a little bit of a side on images, and of course a GIF file does not do lossy compression. So that is one good thing about a GIF, but a GIF doesn't support as many colors as JPEGs and PNG files. So GIFs are not something that you'd want to save that picture of the tornado as. You'd want to save it as a PNG. And of course, since your phone can't take a PNG photo directly, you'd have to save that JPEG and then open it up in GIMP or Photoshop and resave it as a PNG file. Okay, so back to drawing this. So we said in order to work with these, I have to have that CImage file. Remember at the start of this lecture, I downloaded that. So I've already got that downloaded, that CImage file from up at the top of our lecture. It was right here, okay? So let's create a Python program to draw this. Now this is going to be really small because I'm running on a really high resolution monitor on Linux. So this is going to be super small when we draw it. So I'm going to make my canvas actually bigger than this image just so I can actually take a screenshot of it and show it to you. So alright, so we got Tawny out here, okay, and I'm going to go ahead and from CImage import star, that brings that library that was written at Luther College to make our life of working with images easier. Okay, so I brought that into my program. Next, I'm going to create what I call a canvas. This library calls it a image window. So you got to have a window to draw images in. So I'll just call it img win for image window, and then the function that actually creates that canvas where you can draw is image win. Okay, and we're gonna pass some arguments to that function when we call it. The first one is the little title that it puts at the top of the window, just like here where I have Tawny running and it says Tawny-untitled. Okay, this one dot will show up at the top of my window. And the next thing that you pass to it is how wide do you want that canvas, and this is in pixels. So I'm going to tell it I want it 100 dots wide and I want it 50 dots tall. Okay, so that creates that empty window that has nothing in it. And now I've got to create an image so that I can draw in the image, or create dots in the image is a better way of saying it. So I'll just call this empty image equals, and the function is actually empty image. EMPTY image. Okay, and what we're gonna pass to that is actually how big we want that image to be. And so if you look here, we want that image to be, we started at 0 and we counted to 30, so it needs to be 31 wide. You see where I'm getting 31? If you start counting at 0, then that's actually 31 dots from 0 to 30, okay? And we want that image to be 12 tall, right? Because we started at 0 and we're going to 11, so it's 12 tall. So 31 dots wide, 12 tall, okay? So now let's create a pixel. We're going to create this little red dot right here. So we got to create a pixel, and then we can paint that pixel, or drop that pixel into this empty image. So here's the way you create a pixel. I'll just call it, this is just the name of a variable that's going to hold that pixel. Okay, red pixel equals, and the function that actually makes a pixel object is called pixel. Okay, and you might imagine that we're going to have the red, the green, and the blue in here. Okay, and if we said if we wanted it to be red, we'd max out the red, which it can only be something between 0 and 255 here. If you try to put anything other than 0 through 255, she will blow. Okay? And it can't be a float. Each of these three things that's going in these parentheses has to be an integer. Now, you heard me say that. I'll get emails, I'll get calls, I'll have people, ready to, I don't know what, saying that their program doesn't work, and they will have done some kind of math to come up with this number, and they won't have changed this number into an integer, and their program blows. So, all right, let's make our red dot. So, here we go. So max out the red, no green, no blue. That's our red dot. Now we need to place that red dot into this empty image. So let's do it. Empty image dot set pixel. That's actually going to draw that dot. And you've got to tell it where, and remember that this X and this Y stuff here, it's going to be 0 based. So if we want it to be the very bottom pixel on the right, then the coordinates for that, as you can see, it would be over our X coordinate would be 30, right? And our Y coordinate would be 11. This is 0, 0 up here. So 30 and 11 down. Okay. So that's going to set that red dot that we created right here. That's going to set it in our image. Now that we've done that, we need to actually draw our image into our window that we created. Empty image dot draw img when. Okay. At that point, we actually have an image, and we have drawn into it drawn that image into our image window, and we would be seeing this if we ran this program right now, but there's a vital part that we have left out. Please don't leave this out, because when I go to test your programs, it means that you just stole memory from my computer, and it's hard to get that memory back without rebooting the computer. There are a few ways on Linux I can get it back. It's worse on Windows. So if you remember back 14 or 15 weeks ago when we were working with Turtle Graphics, there was something we had to do at the end of our Turtle Graphics when we were drawing shapes and things, that to basically to hold that graphic up on the screen, and also to allow us to click in that graphic and free up the memory at the end of the program. Do you remember what that was? img when dot exit on, if I can type here, on click. This holds that window open for us to be able to see it, and when we click inside that window with our mouse, now it's important to remember that you've got to click inside that window to actually release that memory and cause the program to end. Okay, that's going to create that image, and it will hold it open on the screen for us to see, and when we click inside it, it will release that memory at the end. So let's save this program. We said it was going to be one dot, so file, save as, okay, and I'll save it as one underscore dot py, okay, one dot underscore dot py. So at this point we can run this, and it's going to be really small. So you ready? Here we go. Okay, here it is. It's really small. Okay, now I left out something, so I'm going to have to close this and start over because I left out something in my set pixel here. Notice I told it where to put it, but I forgot to tell it what to put there. Okay, so now I've got everything that's required in for my set pixel. And if you notice here, and you should have picked this up by now in the class, but when you have an error like this in Tawny, if you click on it, do you see where it took me? If you click on this blue underline, it took me right to the line that had the error on it. And most of the time it's pretty good about that. So, alright, so we fixed that error. So let's run it again. So here's our little image, and I doubt you can see it. I can see it here. There's a little red dot right there where I'm pointing to with my mouse. I'm going to take a screenshot of it and magnify it so you can see it. Okay, select that, and I'm going to get in here, and I'm going to do that, and I'm going to save that. Now I've got my screenshot saved right here. I'm going to open that up so you can see it. Okay, and I'm making it bigger. Can you see our red dot right there now? That's the dot that we just drew with this program. And I told you this was really small. You see how small it was, right? Let's see. Let's get to 100%. That's how big that image was that we drew. Okay. Now there are a lot of cool things actually that we could do with this, but when we've got our image created here, our image window created, and our image, we can save this image out to a file. So if I wanted to save that out to a file, empty image.save one.gif. Okay, that is gonna save that image to a file, a GIF file, in the folder where our program is. So let's run it again. Now I'm going to click into that image so that it frees my graphics up. And now if we go out here, do you see our one.gif file right there? If I open that up, there's our image with our one little red dot at the bottom right. Okay, so we've created our first image from scratch. We've actually drawn an image from scratch with Python. Now let's go on and draw a little bit more, or let's do this. Let's make an image viewer, because we've got this GIF file out here. We can write an image viewer in Python, and it'll only be about 4 lines of code. Now, I challenge you to find another language where writing an image viewer to view images is only 4 lines of code. We really like that part of Python. So I'm going to save this as a different file, and I'll save it as show image. Okay, and now I'm going to go ahead and take some stuff out of here because there's some things that we don't need. Okay, and my image win, if you want to follow the exact example that I give you out there, we can call it my image win. Okay, and so we'll create that up here, my image win equals image win. Remember this. Okay, the first thing is the title that we want to be at the top of the window. USS North Carolina. And you'd want this image window to be big enough to show that image. So there are ways that we can load the image in and then get the width and the height. But I'm trying to show you just a real basic example here. So let's make it 400 by 252. Okay. Now, if you're wondering where these numbers came from, right here's the image we're going to show. If I right-click it and do Properties, and I go to the Image tab, what does it say for the width and the height there? 400 by 252. So that's why I'm doing what I'm doing here. But again, there are ways that you could load this file in, get how big it is, and then size your window according to the width and the height of the image, where your program would automatically adjust. Ship equals file image USS-NC-small.gif was the name of the image that we wanted to show. And all we've got to do now is draw it in our image window that we have created. So ship.draw my image win. Okay. Down here, this is going to hold the image window open. We don't need this line to save the image. We've already got the image. So, all right. So how many lines of code was that? If you count the import, I think it's 5 lines of code. So this is our image viewer right here. Let's try it out. Look what we've got. There's the battleship. Okay. So 5 lines of code in Python, and you've got an image viewer. Okay? Not many other languages that you could do that. Can't think of another one, actually. Okay? Now let's create an image. Let's create an image and draw inside it so you can see how we could loop through pixels. Because if you notice right here, we've got a lot of columns. We've got a lot of rows. Okay? If you wanted to process every pixel in this image right here, the way you'd read a book, you'd start at the left top and go across, and once you finish that first row, you'd drop down and you'd go across the next row, and then you'd drop down again. Hopefully you could see that we could use a loop to go through all the columns. We could use a loop to go through all the rows. If we nested the loops so that we had an outer loop to roll through all the rows and an inner loop to roll through all the columns, then we could process this whole image. And that's the way Photoshop and other programs work, is they just roll through and touch every single one of these dots in the image. Okay? So let's create another program. And this time, let's make one to draw a line. We'll call it draw line. Draw line.py. Okay? We still need this much in our program for sure. Okay? So at this point, we still need an image window, so I could have left that in. We're going to create an image window. Okay, the title at the top is going to be diagonal line. Okay, we want this, this is up to you. We're drawing this from scratch. We'll make it 300 by 300. Okay, so 300 pixels wide by 300 pixels tall. Now let's create an image to draw in. We'll call it drawing image equals empty image. And this is actually creating an empty image that we can draw in, and we're making it the same dimensions as our window that we're going to show it in. Okay. Let's create a red pixel again. Remember how we could do that? Red pixel equals pixel, and we pass our colors to it. The first one is the red value, the next one is the green, and the next one is the blue. So this is going to make a bright red pixel. Okay, calling the pixel function. Now let's create just a loop to roll through all those dots in that image. And I can do one loop if I want a diagonal line. For I in, you remember how to do a for loop? Range 299 minus 1 minus 1. Let's talk about what this for loop is going to do. It's going to start, remember our image is 300 by 300. Remember that the computer starts counting at 0. So the very bottom dot is going to be at 299, 299. This is the bottom dot down there. Okay? If I wanted to go up like this, here, 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 here. If I go minus 1 on my X and minus 1 on my Y, can you see how I would keep going up? Just like reverse stairs. Okay? So that's what we'll do with this for loop. This says start out at 299, stop at 0. Remember, it stops 1 before this number, so 1 before minus 1 is 0. This says decrease by 1 each time through the loop. So it's going to start out at 299, then 298, then 297, and so on each time through the loop. Drawing image dot set pixel. We're going to drop that pixel down, and we're going to drop it at I, comma I. Think about this for a second. This is the X where we're putting the pixel. This is the Y where we're putting the pixel. So, and then don't do like we did the last time and forget the pixel. Remember that? Experience is what you get when you don't get what you want. So we had some experience by forgetting to put the red pixel in our set pixel function. Okay, so now let's actually draw that image in our window. Drawing image dot draw, and we're going to draw it in my image win. Okay, so that's our complete program. Let's run it. There's our line. Can you see it? It started at 299, 299. It stair-stepped its way up like so, like I'm drawing with my arrow there, all the way up. So that's the way you can draw in a image, just playing color the dots. Color the dots. Okay? So, back to our lecture here. We've gone through, these are the method summaries for our file image and our empty image and so on. We used the file image to go get the battleship file and load it into an image. Once we did that, we drew it into an image window. Here's where we're talking about the image window methods right here. You can see here's how you use the image window. Okay, here's the exit on click that we were using. Okay, here's some methods that were applied to our file image and our empty image functions. So these are all things that we could do. You saw me use the set pixel. You saw me use the file name. You saw me use the draw. Do you remember I told you we could have made our image viewer size itself to the image? Looky here. If we have a file image, we could do a dot get height and a dot get width. We could use that to size our image automatically. We just have to rearrange that program a little bit. Let's see if I can find that program and we could go back and change it. It was called show image right here. If I did this, if I went out and got my ship before I made my window to show it. So think about this for a second. This is creating a file image right here of the ship, and I'm doing that before I made my window. Then I could actually put right here, I could say ship dot get width. Okay, remember, there's the method right there. Ship dot get width. I could do ship dot get height, if I can spell height. Okay. Now we've got an image viewer that would work with any image. Okay. So if we run this again, you'll see it still works. Okay. How could you make this more flexible? Remember the input function? we could actually make this program ask for the image that we wanted it to show. Now, not sure I could go look in my downloads and see if I have something out there that I could show. Let's see, I've got some pictures here somewhere. It'd show us a picture of myself. How's that? Okay, here's a 200 JPEG picture of me. I'm going to copy that to my downloads and my imaging lecture folder. Okay, so now I've copied that picture of me to the downloads folder. You see where it says Clifton200.jpg? That's a JPEG file, right? So if I do this, file to show equals input, enter the name of the image to show, okay? That's going to do an input. It's going to ask me to type in the name of the image to show, okay? And then right here where I've got this, I could do file to show, okay? And now we've made a completely, how should I put this? A completely versatile, flexible image viewer. Of course, ship's not really the best word, but you could go ahead and try this out now. It's going to ask me what image I want to show, and then it'll load it in, and then it'll show it. So let's run it. Okay, the file I want to show is Clifton200.jpg. When I hit enter, it's saying bad image. Oh, it only works with GIFs. I should have got a GIF file. I forgot about that. Without PIL, it doesn't work with a GIF. With a JPEG. So remember that at the start of the lecture. So let's go ahead and move that to trash. And this would work as long as we had a GIF file. Now we could actually make a GIF file pretty easy if I don't have one already. I don't have one. So right here, if I open that up with GIMP, okay, this is the free program that does everything that Photoshop does, except it's free. And come out here and say export as, and I can save this file to my downloads and imaging lecture, and I want to save it as a GIF. Now you'll see what happens to the quality of this when I save it as a GIF file. Okay. Alright. Export it as a GIF. So now I should have a GIF file out there in my folder for my images. Let's see if it's there now. Downloads, imaging lecture. Yep, there's my GIF file. So let's try running this again now. Clifton200.gif. See, there's the USS North Carolina. Not. Okay. So that's making a flexible image viewer. You can see how we did that. Okay. So last thing in this particular lecture, we're going to make a photo negative image. Now, if most of you may not be old enough to remember film. But the way that worked was when you took the film in and had it developed, you got negatives back where they could use those negatives to print the photos again. The negatives, the colors were actually flipped. So if you want to, let me just download this code and we can talk about what it's doing. I'm going to save it in my imaging lecture. Okay, so I've downloaded this code. Let's go open it up with Tawny and look at it. Negative image. You will need to use this program as a starting point for your project, the last project in the class. And so it behooves us to understand what's going on in this program if you're going to modify it. Hopefully you remember I told you about nesting the loops so that you could process every pixel in the image. So this part right here is the important part that is rolling through every dot in the pixel the same way that you read a book. At least wise most of us read books that way. So this is going to start out at row 0. It's going to start out at column 0, and it's going to roll through all the dots on the first row. It's going to roll through all the columns in the first row. When this loop finishes rolling through all the columns, it'll jump back up to this loop and it'll go down one row, and then this loop will pick up again and roll through all the columns on the second row. And this process will repeat until it's gone through every dot, every pixel in the whole image. So I've put some comments in here so you can see what it's doing. This line is going out there and it's getting a pixel at this column and this row. So this is grabbing a pixel from the old image. Okay? It's saving the old pixel in this variable called old pixel. The next thing it does is it goes down to this line and it calls the negative pixel function. And it's passing the old pixel to it. Now what do we get back when we call the negative pixel function? We get back a brand new pixel. Okay? Now, I said this was the most important part, but let's talk through what the program's doing here from start to finish. Okay? So, here it gets the file, it goes out there and gets the battleship image. It loads it into a variable that's holding the old image. Here it creates an image window just like we did. But notice this. It's making the image window twice as wide as the old image. That's so we can show the old image alongside the new image. We made our window twice as big. Now you don't have to worry about this code. You really don't have to worry about any of the code until you get down to right here where you're calling this function, okay, in your project. But, so, when it passes the old pixel, to this negative pixel function, this function gets a hold of the old pixel, and there are some functions for our pixel object there's a function that gets us the red. So whatever the red number is for that one dot, this gets it for us. Now, if you wanted to flip a color, so if it was white, you wanted to make it black. If it was black, you wanted to make it white. You could do it with this because we're taking 255, which would be as bright a red as you could get. If that pixel was a bright red, it would go to what? 255 minus 255 gives us 0. So it would make it a black color. So this is actually flipping the colors. That's why we call it making it a negative. Whatever was white is going to be black. Whatever was red would be green, or so on. So it's flipping these colors. So we get the red from the old pixel. We subtract it from 255. We get whatever the new red is going to be. Remember that these things right here have to be integers. If you do something with these colors and you don't get an integer back from this operation, when it hits this line right here where it's trying to create a pixel, it's going to blow. Okay? The new red, the new green, and the new blue have to be integers. Okay, so after it's made its new colors, the new red, the new green, the new blue, it makes a brand new pixel right here. That's what this function does, is it makes a brand new pixel. It passes the new red that we calculated, the new green that we calculated, the new blue that we calculated to this function. And when this function runs, it returns a brand new pixel to us right here. And then what do we do at the end of our function? We return that. Come back down here. Each time through, we're grabbing a pixel from the old image. What are we doing? We're setting that new pixel that we created in our function, we're setting it down at exactly the same spot in our new image. So when this thing runs, we will get a photo negative of our battleship. Okay, let's run it. There's our photo negative. Whatever was black is now white. Whatever was white, see the cloud up there? See how black the cloud is now? That's a photo negative. So, that's the way this will need to work for your project, except you need to apply a color formula here. I'll go look at that project in a second so that you have something to go on with that. Now, I'm not going to, well, we can run through this. I'll just download the program and let you read it, and I'll show you what this program does. But this actually flips an image, and this is going to do a mirror image of our image. It's kind of cool that you can pick the dots up on the right and move them to the left. And if you've ever looked in a mirror, everything was reversed. This actually makes a mirror image of whatever image you had. So I'll save that flip image down and we can run it before we talk about the project. So let me go open that up. Flip image, open. Watch what happens here. It took the dots from the left, it moved them to the right. So this half over here on the right is a mirror image of that. It's almost, I still have trouble getting my head around that it works that way, but you can make a mirror image of any image by moving the dots on the left to the right. Okay, so That's the flip image. You could also do, this is doing a vertical flip, because they call it a vertical flip because basically what this is, if you drew a line down the middle of the image, an imaginary line down the middle of the original image, it takes the dots on the left half, it moves them to the right, takes the dots on the right, moves them to the left. That vertical line that goes through the image, that's why they call it a vertical flip. Okay? If we wanted to do a horizontal flip, then the picture would actually be upside down. We'd make the picture upside down. Okay? So, vertical flip versus a horizontal flip. Okay, so let's go look at the project that you have to do, the last project of the class. Are you excited? The last project of the class. So, Module 7, and go down to the assignments, and go down to Project 10. Okay, so this wants us to do a sepia tone. Back in the old days when they took photos on tin and stuff, they actually had a brownish tone to them. If you've really seen an old image, it had a brown tone to it. That was called a sepia tone. And that sepia tone, we can actually convert a modern image like this battleship into a sepia tone. I'm giving you the formula. Now here's, let's see if there's a tutorial out here in GIMP. There's a sepia tone of this child. Okay, they took the original image, they converted it to a sepia tone. Now that's a tutorial of how to do it in GIMP. But anyways, so here's the formula that you need to apply. Now this formula, you will need to apply that to every pixel in the image. So it's going to tell you in the instructions that instead of having a make negative or negative, what was it called in our program that we just did, what was the name of that function? It was called negative pixel. Instead of having a negative pixel, you're going to have a different name for that function if you want all the points that you can earn. Instead of it being negative pixel, it needs to be named make sepia pixel. Okay? That means if you are renaming that function, remember the nested for loops down in the main program? They'd need to be calling make sepia pixel instead of negative pixel. And remember that something is getting passed to that function. Okay? So you're going to rename that function, and then you're going to have some code inside that function to implement this formula. Now, where it says current red, current green, current blue, those things don't exist in this program right now. They kind of do. What's our current red? What's our current red value? How would we get the current red value? We would get the current red by doing this, right? This is the current red. Now you could either save this into a variable called current red or whatever, but if you just try to paste that code, it's not going to work because current red does not exist unless you make it exist. You are the programmer. So some way or another, you're going to have to get the current red, you're going to have to get the current green, you're going to have to get the current blue. You're going to need to multiply them by these values right here. And then after you've done this multiplication, it's telling you in words that you need to divide it by 3. Now, remember, divided is not a word in Python, so you need to understand how to do division. And after 14 weeks of Python, you should know how to do division. Now, what did I tell you about the new red and the new green and the new blue? You remember earlier in the lecture? These have to be integers in order to keep that pixel program, that pixel function from blowing. So you have to make sure that whatever you're plugging into new red, new green, and new blue, it's got to be an integer. And right now, if you get this formula translated, I can assure you that it is not going to be an integer. Because you're multiplying some number by a number with decimals. You're always going to get a number with decimals. You're dividing. Usually when you divide by 3, it'd be a rare occurrence to get something with a remainder of 0, meaning no decimals. So you need to convert this into an integer in order to save it to new red, new green, and new blue, and then you will be making a pixel from those and setting that pixel down in the new image. Now, what I just told you is kind of spelled out for you here. Way back in week 2 or 3, we talked about how to do integer division in Python. It's different from just a slash, so you need to think about that. And you need to think about how you would get these things right here converted into an integer. Unless you can do that, you're not going to get this program to produce what it's supposed to produce. The requirements are down here, and so make sure that you look at each of these bulleted items and make sure that you're satisfying the requirements. Okay? Alright, that's the end of the imaging lecture. I will do a short lecture to talk about factorial, but aside from that, the only things left for you to do are your Project 10, your homework questions. There's no Code Lab in the imaging module. We're done with Code Lab. And the final exam will be available for you at a date that's posted out there in Blackboard. Good luck, everybody. You've been great in the class, and hope to see you around. Stay safe.